Hi, I'm Sandra Porter from Digital World Biology. Today, I'd like to talk about a method we can use to find drugs that might work against Zika virus. One of the quickest ways to find an antiviral drug is to look at drugs that are already being used to treat other viruses. Imagine we have a drug called Drug X that is an effective treatment against a virus. I'll call it virus A. We can ask, will Drug X also work against other viruses, like Zika virus? First, we have to find examples of viral proteins bound to potential drugs. In other words, we're looking for our viral A, Drug X complexes. We can increase our chance of success by looking for proteins that are similar to proteins from Zika. To do this, we'll use BLAST. Next, we need to find out if the drug that inhibits virus A will also bind to our Zika virus protein. To do that, we will identify the amino acids that contact Drug X, and we'll use our sequence alignment from BLAST to determine if the Zika virus protein contacts these amino acids at similar locations. Let's begin. First, we use BLAST to identify potential drugs bound to viral proteins. I already did my BLAST search using a Zika virus protein as a query. Now I'm going to look at my results and pick some proteins to investigate. I decided in my BLAST search to look for drugs that would inhibit the NS3 protease. Looking at the conserved domain map, I can see that I'm going to want to focus on proteins that align between amino acids 1 and 200. Now, I want to look through my results to find proteins that are bound to potential drugs. I can start by using the find command in my web browser to quickly scan my results. The find command in most apps is Command plus F or Control plus F if you're using Windows. To use the command, I press both of these keys at the same time. If I'm using Safari, a window opens at the top of the web browser page where I can enter my search terms. One of the words I use to identify a potential drug is inhibitor, because drugs inhibit the action of a protein. You can see I have some results to look at from this search. Another word I can use is complex. This shows me proteins that are bound to other molecules. Some of these are potential drugs. Another way I can find possible structures to investigate is to look at the alignments. If a protein is identical to another protein chain, these are grouped together in the BLAST results. I click the link to see more titles. If a protein is a homodimer, I'll see a link to the other subunit since those sequences would be identical. But sometimes I'll see a case where the same protein is bound to a different molecule that, again, might be a drug or inhibitor. In this case, aprotein is a protease inhibitor. Now we have a drug-protein combination to investigate, but how do we determine if our Zika virus protein could bind to that same drug? The way we're going to do this is we're going to identify the amino acids in our protein that contact the drug and use our BLAST results to see if the Zika virus contains those same amino acids in similar locations. I open Molecule World and use the PDB ID to find and download the structure. In this case, I had already downloaded a structure to investigate. This protein is not bound to a drug, it's bound instead to a nucleotide, GTP, guanosine triphosphate, but it will work as an example. I open the sequence viewer and touch the GTP to select it. To find amino acids close to GTP, I touch the selection button and choose Select Nearby. Amino acids near the GTP are highlighted. I change the coloring style to residue and the drawing style to spacefill. My amino acids are now colored by residue and the GTP is shown in white. I change the atom visibility to show all the atoms so I can see the side chains. Now, I'm going to hide some of the residues that are farther away so I can focus on amino acids that form bonds to the GTP. I scroll through the sequence and touch the one-letter abbreviations to see where the amino acids are located in the protein. When I touch a residue, it will turn dim in the structure, showing me where it can be found. I can see here that this methionine is not very close to the GTP. I keep scrolling through the sequence and I come to an arginine. That residue is right next to the GTP, so I touch it again to keep it selected. The lysine nearby is also close to the GTP, so I touch that to keep it selected too. If I'm not sure if a residue is close to the GTP or not, I can zoom in for a closer look. Now I'm going to hide all the unselected residues to make it easier for me to tell what needs to be removed. I continue scrolling. Now I touched a glycine by mistake, so I just touch it again to deselect it and move on. This tryptophan is a little far away from the GTP, so I keep it deselected, but the aspartic acid right next to it is right near the GTP, so I highlight that one again. I keep scrolling. I continue this process of deselecting and hiding amino acids until I've hidden all the residues that are far away from the GTP. Now that we've identified amino acids that are important in binding, we can ask if those same residues are present in the Zika virus sequence. I copied the alignment from my BLAST results to a document in Microsoft Word, and I changed the formatting to Courier with a font size of 9 to make it fit on the page. I look at the sequence in my iPad to find the highlighted amino acids that I identified earlier, and I search for those sequences using the Find command in Word, or I can enter the sequences in the upper right-hand window. I like to use a 3 to 4 amino acid sequence when I search, so I can be more confident I'm finding the right sequence. When I've found one of my amino acids, I compare the sequences nearby to the sequence in the Molecule World Sequence Viewer to confirm that it's correct. If I can see that the amino acids that bind the molecule in my subject sequence are present in my Zika virus query, I can be pretty sure that the Zika virus protein is likely to bind to this same molecule.